In 2021, a builder in upstate New York put up a 400 square foot structure. No lumber, no concrete, no steel frame, total material cost under $1,200. Load tests passed. The same square footage in a conventional stick frame build in that county averaged $68,000 that year. 6 weeks after that mycelium structure went up, the county condemned it. Not because it failed a test, not because anyone got hurt, because no building code in the United States legally recognizes mycelium as a structural building material. That is the contradiction we are going to spend the next 10 minutes inside. Mycelium is the root structure of fungi, not the mushroom above ground, but the dense, thread-like network underneath it. Those threads are called hyphae. Pack them into a mold alongside agricultural waste, such as hemp hurd, corn cobs, or straw. Give them 5 to 7 days in the dark, and something remarkable happens. The organism eats through the substrate, colonizes every fiber, and binds everything together into a rigid composite. This wall doesn't get built. It grows into shape. No heat curing, no adhesive, no fossil fuel input at any stage. You pack a mold, inoculate it with spawn, and wait. What comes out is a panel that can insulate your wall, resist fire, and cost you less than $1 in raw materials. This is not fringe theory. Ecovative Design, based in Green Island, New York, commercialized structural mycelium composites starting in 2007. They currently supply mycelium-based packaging to Dell, IKEA, and Sealed Air Corporation. NASA has been funding mycelium habitat research since 2018 under its Myco architecture project, specifically for lunar and Martian construction. The agency's reasoning? You cannot ship building materials to Mars, but you can ship fungal spawn and grow your shelter from local organic waste when you arrive. Structures made from mycelium composites are being grown and tested in the Netherlands, rural Portugal, and New Zealand. But here in the United States, where the housing affordability crisis is pricing millions of families out of homeownership, the material is effectively banned from residential construction. The performance numbers are worth sitting with. Ecovative's Myco board panels test at 30 to 50 pounds per square inch compression strength, comparable to expanded polystyrene foam, and viable for non-load-bearing wall infill within a timber or post-frame system. Thermal performance lands at approximately R3.0 per inch versus R3.7 for standard fiberglass batt, within 20% of the industry default. On fire resistance, the material is self-extinguishing in ASTM E84 surface burning tests, with a char rate between 0.5 and 0.8 millimeters per minute. Kiln-dried pine chars at 1.0 to 1.2 millimeters per minute. The mycelium panel burns slower than the wood frame holding it. In 2019, researchers at Brack University tested mycelium bamboo hybrid wall panels in flood-affected coastal Bangladesh. The hybrid structures outperformed concrete block construction in hydroscopic recovery, the ability to survive flooding without structural failure. After a catastrophic flood, the mycelium walls could be composted and regrown. The concrete walls required full demolition. Now the cost gap. Mycelium panels grown at home run $1.20 to $2.80 per square foot in raw materials. A conventional insulated wood frame wall system runs $12 to $18 per square foot installed, based on RS Means 2024 data. On a 1,500 square foot home, that gap translates to $15,000 to $22,500 in wall material savings before labor. The hemp hurd substrate costs roughly $0.08 per pound. A standard wall panel uses about 4 pounds. That is $0.32 in raw feedstock per panel. Who decided this material wasn't allowed in your house? The International Code Council, the ICC, writes the model building codes adopted by most United States states. Their member organizations include the Concrete Masonry Association of America, the American Wood Council, and the Gypsum Association. Those organizations represent the industries that sell you the materials Mycelium would replace. New materials can gain ICC recognition, but the pathway requires applicants to fund independent testing, pay evaluation fees, and navigate a multi-year review process at an estimated cost of $200,000 to $400,000. No commercial entity has completed it for Mycelium in residential structural applications, not because Mycelium failed the testing, because no one with $400,000 has a financial incentive to open a market that competes with $60 billion in annual United States lumber sales. Your county building inspector is not the villain. Local inspectors can only approve materials listed in their adopted code. When they tell you Mycelium is not allowed, they are not making a structural judgment. They are reading a list written by an organization whose member dues come from industries that benefit from Mycelium staying off it. The agricultural exemption is the legal gap most Mycelium builders are currently using. In most rural counties, outbuildings on working farms below 200 square feet require no permit, and some jurisdictions extend that to 1,000 square feet. Owner-builder exemptions in 38 United States states also allow you to build without licensed contractor oversight on property you own and intend to occupy. Here is how to start. Hemp, hurd substrate, the woody core left after industrial hemp is processed, runs approximately 8 cents per pound. A 50-pound bale, costing $180 to $220, grows roughly 50 to 60 standard wall panels. Source Mycelium spawn from Fungi perfecti in Port Townsend, Washington, or North Spore in Portland, Maine. A 5-pound bag of oyster Mycelium spawn costs $20 to $35 and inoculates 40 to 60 pounds of substrate. Pasteurize your hemp hurd at 70 to 80 degrees Celsius for 1 hour. Not sterilizing, just killing competing molds. Cool to below 30 degrees Celsius before inoculation. Use a thermometer, not your hand. Mix spawn into substrate at 1 pound per 10 pounds by weight. Pack firmly into molds. Polypropylene containers work well. Seal loosely for gas exchange. Colonize in the dark at 70 to 75 degrees Fahrenheit for 5 to 7 days. A fully colonized panel looks like a solid white brick. Unmold and kill the growth by baking at 200 degrees Fahrenheit for 2 hours. To bond panels at joints, pack fresh inoculated substrate between them and allow 48 hours for recolonization. The Mycelium grows across the seam and fuses panels permanently. The total first batch cost to grow structural test panels is $50 to $80, including spawn and substrate, based on documented build logs at Permies.com and the Mycelium Underground Forum. Start with a single 12 by 24-inch test panel. Load test it yourself. Document the result. Then build a 10 by 10 foot outbuilding under your county's agricultural exemption threshold. Document every step. That documentation becomes your evidence package if you later pursue a variance for permitted residential construction. What makes this material work at the engineering level is chitin. As hyphae grow through the substrate, 2 to 10 microns in diameter, thinner than a human hair, they enzymatically break down the lignocellulosic fibers in the hemp hurd and thread physically through the matrix. When those hyphae die, they deposit chitin, the same structural polymer that makes crustacean shells rigid, as a cross-linked composite throughout the panel. Chitin is naturally hydrophobic, which is why Mycelium panels resist moisture absorption better than untreated wood at the material level, not just through surface coating. The honest performance envelope. Compression strength at 30 to 50 psi is not sufficient for load-bearing structural applications on its own. Mycelium panels belong inside a timber or post-frame system as insulated wall infill. Thermal performance at R 3.0 per inch is within 20% of fiberglass batt. You close that gap by adding roughly 15% more thickness. Fire performance at a char rate of 0.5 to 0.8 millimeters per minute is genuinely better than kiln-dried pine. The material NASA is funding for Mars habitat construction is simultaneously illegal to use in a garden shed in most American counties. The agency chose Mycelium for Mars because you cannot ship construction materials from Earth, so you grow your shelter from local organic waste when you arrive. That logic applies equally to a rural property owner in Montana who has hemp stalks, fungal spawn, and no desire to pay $18 per square foot for fiberglass bat. Mycelium physically fuses agricultural byproduct into a rigid, fire-resistant, thermally insulating composite with no heat, no adhesive, and no mined materials. The ICC approval pathway costs $200,000 to $400,000. It is a barrier no small builder can clear, and a pathway the lumber and gypsum industry has no incentive to fund for a direct competitor. Ecovative's material has been in commercial use since 2007. It passes fire tests. It passes load tests. It costs $0.32 in raw feedstock per panel. This week, do 2 searches. Search your state name plus owner-builder exemption statute. Then search your county name plus agricultural structure permit threshold. Those 2 numbers tell you exactly how much you can build right now, legally, without a permit, without an inspector, and without spending $15,000 on wall materials that a fungus could grow for you in under a week. Have you ever looked into mycelium construction or tried growing your own panels? Tell me in the comments.